So our project was the investigation of ultrasonic cleaning on the fatigue life of gas turbine components, sponsored by Pratt & Whitney, with our industry advisor being Scott Webb and our academic advisor being Professor Suk Woo Lee. I'm Marin Bulko, along with my colleagues Jeet Rosa and Sam Schaefer. So the main problem, our goal was to observe whether or not ultrasonic cleaning has a measurable effect on fatigue life. Failure due to cyclic fatigue has been observed in turbine parts that reach their natural frequency during operation. Concern from our sponsor has been raised that a similar phenomenon could occur during the high frequency ultrasonic cleaning of parts. Fatigue life debit caused by ultrasonic cleaning could result in premature failure of these parts. And it would cause an effect on the surface structure and the microstructure.
In order to match the natural frequency of our cleaner to our samples, we use the Euler-Bernoulli free beam equation, which can be seen below. In this equation, D represents the diameter of a rod, L represents the length, F represents the frequency in hertz, rho is the density of the material, and E is its Young's modulus. Beta L squared is a constant which can be calculated from the equation cos beta L cosine beta L equals 1. In these images, you can see examples of different modes of bending, which would attribute to different L values. So in order, our sample, we cut it to a length that would match the frequency calculated for our 34,000 hertz ultrasonic cleaner. We utilized a wire fatigue testing machine in the MSE undergraduate labs to conduct low cycle fatigue testing at controlled displacement.
So these graphs are what we were able to glean from the aforementioned fatigue tests. So on the left, you can see we have a hysteresis loop before the ultrasonic cleaning. So that's our control sample. And on the right was after 3 hours of ultrasonic cleaning. So you can see they have very similar shapes. If we were to expect a large life debit to be incurred, the area should be greater on the right, because that represents a larger strain energy. So therefore it'll be stretching in the grips more with less load. And so the parameters that we used on the fatigue tester was a precision controlled ramp up to, or a 50-pound ramp in tension, and then a 0.005 inch extension for 500 cycles. And these are the graphs that we were able to generate from that. So in the future, this is, we left off at a great point for another team next year to pick it up. They already know the procedure that they will be following. They will be just putting the wires in the bath and then in the fatigue tester. There are some things to note though. You have to be careful because if the parts are in the bath, they could scratch and damage the surface, leading to results that we don't really want. We want to focus more on the vibration caused by the bath itself. And we could also, next year, they could also recreate the conditions of the original failure, and that would include changing variables such as the water level and the number of parts in the bath and the total time spent in the bath. That is all. Thank you for watching this video. Thank you from all the members of our team, including our academic advisor and our professional advisor.